Okay, so sorry about my Wi-Fi issues today, guys. So I'm making a recording to post this instead. Okay, so today, what we're looking at is rotational kinematics and rotational dynamics. Specifically, we're doing a lot more rotational dynamics problems. Some of the kinematics just sort of factors in some parts of the problems. Okay, so what is the difference between rotational kinematics and dynamics versus linear kinematics and dynamics? So we've done a lot of stuff with linear relationships. So linear kinematics equations here, right, where we're finding our velocity or our distance or the height traveled. And when we're looking at it, we're looking at it along a direction, whether that direction is x or y, right? A linear direction. But when we're dealing with an angular system, we're looking at how an object is traveling uh, around a radius as it's rotating in a system. So these equations look very similar, right? When we set them up. So our angular velocity versus our linear velocity, these relationships look almost exactly identical. Some major differences, though. When we have angular velocity, we're moving around a circle. Angular acceleration, obviously, as well. And then one relationship that I think is really important to look at is if we're trying to figure out the distance that we've traveled, so let's call this some delta theta, right? Which we would see maybe in this equation right here, right? Theta minus theta naught, right, would be equal to some delta theta. If we want to find the length, the arc length that a that we've traveled based on some angle, some delta theta, uh, the relationship for that is going to be equal to, so the change in s, right, the change in that distance around the circle is going to be equal to r times some delta theta. Okay. I saw some mistakes in the midterm where people treated this like a speed. That is not true. So it's just going to be r times some delta theta. Okay, so I'm going to break these up into pieces. So we're going to look at these problems one by one and I'll record them separately. Before I start, so when we looked at linear dynamics, we did a lot of things where we had sum of forces in the x direction, right, and sum of forces in the y direction equal to some mass times some acceleration or sometimes equal to zero. And we use that to figure out our systems of equations, okay? In this case, when we're dealing with angular relationships, uh, in our system, we also have something called a torque, okay? And a torque, this I here is a mass moment of inertia. We have a table with general formulas. This mass moment of inertia depends on the shape of the object. Um, it depends on the shape of the object, and that tells us a little bit about how it is uh, resisting an angular acceleration or how much inertia it has when it's moving. And this is our angular acceleration. So basically, when we're doing these problems, we would have sum of forces in the x and sum of forces in the y for a lot of the problems that we're going to see today. We also have a third equation where we have the sum of torques, and that's going to be equal to the mass moment of inertia times some angular acceleration. Now, the mass moment of inertia for a system, we have general equations. So if we have something like just a circle or a disk or something very standard, we're just plugging in a standard value. That's some relationship of the mass and the radius of the system. But if we have multiple objects in a system, we may need to separately calculate our mass moment of inertia, like we'll see for one of the problems today. But essentially, the main takeaway is that dealing with linear systems and angular systems, there's a lot of similarities. The relationships between these equations are analogous, but we can't set the sum of torques like equal to a force. Um, we're not really doing that here. We are looking at them separately, and it just basically gives us one more equation for the system to relate our variables. I understand that might not make sense right now, but let's jump into some examples, and I think it'll definitely help clear things up.